Right, 8.5 is phenols. The way that you make a phenol is you start with the sulfonic acid, which we learned how to make in the aromatic chapter, and you add sodium hydroxide and you add acid. Okay, so it's a combo. Sodium hydroxide, and then second step is adding acid, and you make a phenol. You also form SO2 gas and water and a whole bunch of other stuff, but we're not going to really talk about that. Okay, so that's how you make a phenol. That's basically all I want to talk about in this chapter. Everything else we've talked about before, so they talk about SN2 reactions and how to make the alkoxide, so you can read that on your own. We are also going to skip 8.6, so skip 8.6. This is about ethers. Nothing really exciting about it. They just kind of give you some more information about ethers. All right, 8.7 is about epoxides. We've already learned epoxides. This book does a lot of the same reactions in different chapters, which is good because you get to see it again. Remember, it's MCPBA. All right, now that you know how to kind of name compounds, let's look at what MCPBA is. I might have talked about this before, but it stands for metachloroperoxybenzoic acid. So this is a benzoic acid. It's a peroxy. It has an extra oxygen. It's highly oxidized form, and you have a chlorine in the meta position. And basically, this oxygen is the one that gets attached to your ring, or I'm sorry, to the pi bond. All right, and that's how you form epoxides. Okay, what can you do with epoxides? Well, you can do a lot with epoxides. One of them is you can turn into a diol, and this is something that we have learned too in chapter 4, but we'll do it again. If you add acid and water, remember you get the trans diol. Okay, so you get an OH and you get the OH on the bottom. We've talked about the mechanism. The OH comes from the opposite side and pops open your ring. Okay, just as a kind of a test, how do you make cis diols? What reaction have you learned that makes cis diols? Why don't you shut off the video, or I guess it's a video, and why don't you think about how you make a cis diol? Right, the way you make a cis diol, hopefully you remembered, it was chapter 4 reaction. It was KMNO4 in base. You make a cis diol. So different reagents for a difference in stereochemistry. So going from cis to trans, you actually completely change the reaction. All right, kind of interesting. And that is chapter 7. Chapter 8 is on thiols and sulfides. These are sulfur-containing compounds. Basically, anything you can do with oxygen, you can do with sulfur. Same types of reactions. Thiols are the kind of the alcohol equivalent of the sulfur compound. So instead of an OH, you have an SH. And sulfides are the ether equivalent, where you have two R groups on either side of the sulfur. You might see this word mercapto a lot in other classes. That implies a sulfur molecule. All right, I think it's Greek or Latin for sulfur. We're not going to learn how to name any of these, so don't worry about any of the naming. Basically, sulfur compounds smell. They have a really pungent smell. The skunk odor is actually smell. The main ingredient in skunk, and the skunk smell, is that compound right there. And it has a pretty harsh smell to it. There is some sulfur. There's things called disulfide bonds, which is or they sometimes call it a bridge in biochemistry. If you take biochemistry, you'll talk about these disulfide bridges, and it's two sulfur atoms hooked together. A lot of our proteins actually have these bonds, which kind of make our proteins have a coil in it, or a turn. Our proteins are not straight molecules. They're blobs of molecules, and they have a bunch of twists and turns, and they're held together by these types of bonds. We're not going to talk too much about this chapter, but just know that however you make oxygen-containing compounds, you do the same thing with sulfur-containing compounds. And that is it for chapter 8.